sequential search is means any one of the technique. If you are going to do linear search, if you are going to do binary search, that comes under sequential search. I didn't understand why they have given separately. I think it is mistake. Sequential search, it should come over here. That this name should come over here. Sequential in that linear and binary search. Okay, don't think that a sequential search is something a new concept. So if you are going to see detail, okay, under the sequential search, we are going to have, means mainly it will represent linear search only. Okay, so insertion, selection, merge, quick, completed. Only heap sort is pending. I told you the creation of the heap tree, max heap tree, is going to be called as heap sort. Okay, not like a sorting technique. Arranging the elements. If I am going to retrieve the heap sort, always I will get the largest element. Okay, so the same technique, that is creation of the heap tree, max heap tree, is going to be called as heap sort, students. Okay, so there is no heap sort technique like the remaining, means take a data, arranging the data. No, we have to create the tree. So for that, first we should learn the trees concept. So that's why I'm keeping this concept as pending for you. The remaining fourth unit is completely. So first unit, second unit, and fourth unit are completed. And if you are going to see the third unit also, I completed aerial trees. This is practical part completely. Okay, so next red black trees I completed. Next binary search trees and operations. Okay, insertions and deletion operations we completed. So what is left for you is generally trees, binary trees, pre-order, in-order, post-order. Theoretically I completed. Now I am going to explain the traversal techniques of the by means of the practical. Means if I want to create a tree, definitely I want to traverse the tree. If I want to traverse the tree, means traversing means printing the elements. If I want to print the elements, then the options we are having is by means of pre-order, in-order, or post-order. So to complete one single binary tree program, I required nearly 2 to 3 days of 2 to 3 days is required to complete single program, students. Okay, so hardly this tree traversal concepts of in order, pre-order, post-order, and the representation of the tree, array representation, and linked list representation. Today I am going to explain how to represent by means of array and linked list. Mainly we are going to get only linked list representation, so that's why I'm working with the linked list representation. Okay, one program is more than enough, but still I'm going to work with maximum programs on the trees. Okay, then we are going to have the graphs. I told you graphs is going to take only 2 days of time. The reason is definitions and representations is 1 day. Only 2 algorithms are there, Prim's and Kruskal's algorithm. B trees already on the last day before the Sankranti I completed the B trees. This part is completed already. Inserting a B tree and deletion of the B tree. You people have already learned this in the DBMS also. The same concept, no practical concept. Okay, is it clear, students?
Okay, miss.
Yes. Okay. Yes, so only this is pending. So I told you, if you learn tree creation, then we can able to write. Only this one is pending. Sequential, as the name should come over here, it is a mistake of the theoretical. Okay. So today I'm going to explain about the binary tree. Okay, so we have learned different types of tree techniques. Okay, if you remember, I discussed about AVL trees, I discussed about max heap, min heap trees, I discussed about the red black trees, I discussed about the binary search trees. Okay, so these are all the concepts. Whereas root, left hand side, the smaller elements must be there, right hand side, the larger elements must be there. These are the rules for the binary search tree, from binary search tree. Now I'm going to work from the basic tree or binary tree. Okay, a tree and binary tree difference is binary. If I'm going to say, children must be 0, 1 or 2, not more than 2 children is going to be there. So if I want to work with the tree, compulsory means all the Q code also you have to write. It means if I'm going to take a tree code, okay, Q code, you have to include complete Q, means insertion, NQ code, DQ code, what is that one, is empty, is full, everything, whatever we have learned the Q code, along with the Q, we have to write the tree. That's why the program is quite lengthy. If you are going to see two different codes, we are going to combine. Okay, so those who are having the Q codes, please make it ready with you. So then we can start with the tree code. Today it's not possible. Today I'll explain the concept and I'll explain how to create the tree, because three different concepts are. Suppose if you are going to write a stack, it's very easy. If I'm going to do push, then you can write display function. If I'm doing pop, then you can write display function. In a trees, if I want to display the data, please remember students, if you want to display the data, displaying the data is nothing but traversing of the tree. Traversing of the tree means in which order you are traversing. Are you traversing pre-order? Are you traversing in order? Are you traversing post-order? Or are you traversing level order? So any one of the technique we have to use to print the elements. So means if I am going to write the tree program, so what are the requirements what are the concepts we require is, if I am going to write tree, the prerequisite is complete Q code you have to write, all the Q functions, and along with the pre-order, post-order, in order. If you are interested, then you can write a level order, and then you have to write the create function. So that's why, so combination of all the codes. So I can't explain all the codes at the same time. Today I'm going to explain how to create a tree. So tomorrow I'm going to explain how to write down pre-order, post-order, and in order, along with the theoretical part. So one order we will write and one answer we are going to get. So this whole concept is binary tree, one single program. I'm not working with the arrays, I'm going to work with the linked list. Okay, so this is the concept. So first one, yeah, don't keep me unmuted. Okay, so muted students. Good morning, Satyam. Good morning, Bharti. Good afternoon. So a little bit of different concepts, students. So theoretically, how much importance is there? Practically also that much importance is there. So I can say that 90% this trees concept, whatever I'm discussing, it comes in the theoretical part only. 10% it is a chance we are going to get in the practical part. As I know, we are going to have only 3 questions, and out of 3 you people have to execute 2. So stacks are there, queues are there, linked list are there, sortings are there. So most preference will be given to these concepts, and a 10% preference will be given to the trees. Okay, at least learn the concepts. So what I'm going to explain is binary trees. So if you want to represent the binary tree, children must be 2 or more, 2 or less than 2. So if I'm going to take A, so B, C, I can have, means the node can have single child, or the node can have 2 children. But a node should not have more than 2 children. This is not going to be called as a binary tree. First important point you people have to represent. This is not a binary tree. Only 2 children are going to be there. So that's why left child, right child. While working also, it will be very easy for us, because we are going to write the code. If left child is existing, write the left child code. If right child is existing, write the right child code. So that's why that binary tree, the children are, maximum children are 0, 1 children and 2 children. And next here, there is no rule in the binary trees that left hand side the elements must be smaller, right hand side the elements must be greater. You ask according to the way how you are receiving the data, we need to arrange the tree. Okay, so no root should not be in the middle. Okay, so if I'm receiving the elements 5, 3, 8, 5. Okay, so if you want to keep it as a left child, if I want to keep it as a right child. Okay, now I got 7, I got 6, 2, 1. So upon the arrival of the elements, we are arranging the tree. So we are not comparing whether it is smaller or bigger, which one should be root, which one should not be root. No concepts. According to the arrival, we are going to arrange the data. And one more thing, trees are non-linear data structure. Please remember this point, students. We discussed with the linked list that is going to be called as linear data structure. So generally to confuse, the questions are explain any one of the linear data structure, explain any one of the non-linear data structure. If the question is non-linear data structure means trees, linear data structure means linked list. Okay, so now how I have to write this tree in the form of array representation, in the form of linked list representation, as we have to follow some rules. Is there any formulas associated with the arrays? Is there any formulas associated with the linked list? So this is the concept. So the concept is what is a binary tree? Explain the tree with array representation and binary linked list representation. So whatever the concept I'm explaining, the same thing you people have to write. Take a tree. Take an example tree. So this is a binary tree. Yes, this is a binary because each and every node is going to be have as two children. Okay, is it a complete binary tree? Yes, it is a complete. I discussed one day what is a complete binary tree and what is a full binary tree. Okay, so how we have to represent by means of an array? So how many nodes are there? 1, 2, 3, 4, 5, 6, 7. So you have to take, just a second, students. Controller so 7. So 0, 1, 2, 3, 4, 5, and 6. So how I have to represent this? This one means we have to enter the elements level by level order, students. Okay, there are 4 different orders will be there. The orders are pre-order, in order, post order. Already I discussed one Friday, I think so. Very less people are there in the class. I explained how to access the elements also. Once again, I'll explain and I'll write the code. So if you want to work with the array representation, we are going to take level by level. Level by level means first level, which element is there? A. Second level, what are the elements are there? B and C. Third level, what are the elements are there? D, E, F, and G. Yes, so we have to store the elements level by level in the array. Okay, so is there any relationship is existing while we are writing this level by level order? Okay, we will check that one also. Take the element, take the index, take the left child, and take the right child. Okay, suppose if I am going to take the element A, okay, so those who are having the problem working with 0, 1, 2, 3, we can work with 1, 2, 3, 4 also, students. So for easy understanding, As we know that array starts with 0, okay, you can work like this. So take 1 array. What is the index value? 1. Okay, so what is the left child value? Left child is B, so left child index value is 2. What is the right side index value? 3. Okay, now take one more value. It's okay, so B. So what is the index position of B? 2. So what is the left child of B? Left child of B is D. D ka index 4. What is the right child index value is 5. Suppose if I'm going to take C, the index is 3. The left child value, C ka left child is F. What is the index
6.
value? 6. And the right child value is 7. So now we should find the relationship between the left child and the right child of each and every element, because by seeing the array I can able to write, but when we are developing the code, okay, we should know the relationship. So what is the relationship of the left child is? Please make a note, students. If I is the index, left child will stay at 2 times of I. Right child will stay at 2 times of I plus 1. You take any one of the child, okay? Take C, okay? C index value is 3. Yes, 3 times of 2, what we are going to get? 6. 3 times of 2 plus 1, what we are going to get? 7. Yes, students, able to follow?
Yes, ma'am.
Yes, ma'am.
Yes. Similarly, if I want to find the parent relationship, if I want to find the parent, okay, parent of any particular index, so the formula is I upon 2. Yes. The parent is I upon 2. So what is I upon 2? Suppose take the index is G. What is the index of G? G ka index is 7. 7 upon 2. So we are going to do the floor division. So 3.5 is the answer. 3.5, the parent is going to become as 3. So for the index 7, the parent is 3. For the index 7, the parent is 3. Yes, for the index 7, the parent is 3. We are getting correct answers or not? Yes, we are getting the correct answer. Now I will check with one more parent. Okay, I'll take the parent of 4. 4 of 2, 2. So 2 index. For the index 4, the parent is going to be 2. For the index 4, the parent is B2. Are we getting the correct positions? Yeah.
Yes, ma'am.
Please make a note, students. Please make a note of these relationships. Very, very important. Theory means something new will not be there, something will be there to muck up. Nothing, students. Everything is the formula related, especially in the data structures. You don't have to read para by para. Nothing is there. Whatever is there, just you have to represent clearly. That's it. Learn the formulas, write down, learn it clearly. So the question is, what is binary tree? What is its array representation? Then you have to write like this for the index I, left child, right child. In left child, relationship is 2 times of I. Right child, relationship is 2 times of I plus 1. How to find the parent? I upon 2. Generally, we will go for the floor operation. So 3. We are going to get the answer. Yes, clear, completed.
Yes, ma'am.
Okay. Suppose if you want to find for the linked list representation of the same concept, okay, how I have to write that? Yes, students, if I am going to take a particular node, a node, I'm having left child and I'm having right child. It is similar to which type of linked list, students?
Double-ended.
Yes. So whenever you want to represent the tree, so which linked list we have to take? doubly linked list we have to take. So remember, class, node. How many data paths we are going to have? One is left child, another one right child. Left is pointing to whom? Left is pointing to some other node. What right is pointing? Right is also pointing to some other node. So how I have to write the code? Node star left child or left child. Next, what is the middle part? The middle part is the data part. What right child? Right child is again pointing to the node. Node star right child. Yes, how to create the node? So if you want to represent the array, okay, array representation. If I want to work with the linked list, so which linked list we have to consider? We have to consider the doubly linked list. Okay, each and everything we have to represent by means of nodes format. So it is a data part is going to be there. Left hand side we are pointing, right hand side we are going to point the data. The concept is much similar to your double linked list. So the code, whatever we have learned in the double linked list, again we are going to learn the same concept over here. Yes, clear up to here, students?
Yes, ma'am.
Okay, now the question is, we are going to have array, we are going to have linked list. Why I am learning with the linked list? The reason is, array means we can store the data in the stack memory, or we can store in the dynamic memory. Linked list, or we are working with a doubly linked list. So where we are accessing only with the dynamic memory. So that's why generally we work with the dynamic memory concept. We don't work with the this stack memory. Okay, array representation of the stack will not be asked. Trees. So you people are going to learn the maps, set maps. I told you in the advanced C++ also. We don't work with the static memory. We work with the dynamic memory. Okay, so with that basic, I'm explaining all the concepts in the dynamic, because the reason is in the C# also you are going to have this concept, the collection classes. Java also you're having the collection classes. Advanced C++, STL we are also going to call having the template classes. So the same concept, multiple number of times we are going to use predefined functions. So dynamic memory. So that's the reason I'm also working with the linked list concept. Okay. Now, so from where? Yes, is it clear, students, up to here?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Array representation, another linked list representation. Now, from where this queue concept has been coming into the picture? Now, I'm saying that if you want to work with the linked list, compulsory queue concept must be there. Why I require the queue concept? So try to understand. So the same example I'm going to take. Suppose if the example is 5, 3, some 8, some 7, 6. Okay, 2. 1. Suppose if there is no element. Okay, let's consider no element is there. So this is a tree. I want to convert this tree in the form of code format. So how we have to start our work? So first what we are going to do is, first we are going to take the queue. Okay. So what is the scenario of the queue, students? Why I can't take stack? What is the scenario of the queue?
The stack is not double-ended, miss.
No. Not about the double-ended. Means on what basis the queue works? Queue is first in, first out. Stack is last in, first out.
Yes, miss.
Yeah. Yes, queue is first in, first out. Stack is last in, first out. So we cannot work with the stack. Whatever the last element we have inserted, from there we have to start doing the work. Whatever the first element we are going to take that element. Okay. What are the elements we are going to have? 5, 3, 8, 2, 7, 6. first element I'm taking and I'm converting in the form of a tree. Okay, so that's why whenever we are working with the trees, okay, the elements are going to be stored in the queue, not in the stack. Please remember, we can't store the elements in the stack. We have to store the elements by means of the queues. Yes, students, if you remember physical data structures, how many physical data structures we are having, students? How many physical data structures we are having, storing the data, in how many ways I can store the data? 2. Thank you, Shaudesh. Thank you so much. What are the 2 different ways of storing the data into the memory, students? What are the 2 different? One is array, another one is linked list, students. If you want to store the data, I can store by means of an array or I can store by means of the linked list. Okay. Now, if I want to retrieve the data, what are the different ways I can implement, I can retrieve the data? One is by means of stack, another one by means of queue. Okay, now different type of traversals we are going to have is the trees. Yes, this is storing the data. This is retrieving the data, storing the data. If I want to store the data, only 2 ways I'm going to have, array or linked list. Now I can call the values in different ways. Last in, first out, first in, first out. Okay, non-linear data structure, linear data structure. So now what I'm going to do, I am storing the elements in the array format. Okay, you are storing the elements in the array format. How you are retrieving? I'm retrieving in the format of queue and I'm constructing a tree. 3 concepts are there. Storing the elements in the form of an array, retrieving the elements by means of the queue, and I'm constructing a tree. Yes, students, able to understand how many concepts we are combining?
Yes, ma'am.
Okay, if you want to store the elements, I'm having only one way, linked list or array. Okay, chhod do linked list. Okay, I'm storing the elements 5, 3, 8 to 8. Okay, you store the elements. Now, how you are want to retrieve the elements? I want to retrieve 5 and I want to convert into a tree. Okay, first element inserted, first element deleted. So, which data structure you are using? Q data structure you are using. Okay, so that's the reason compulsory Q code we have to learn. Okay, Q code is compulsory. Okay, so what I am going to do first, which element? Okay, first take an element into the queue. Now, what is the first element? The first element is 5. Okay, so what I have to do? The first one is I have to create a node. Which node I am creating? I am creating node 5. Okay, so now what is the next element? 3 and 8. Take out the element 5. Okay, I have take out the element 5. So how we can create a new node, students? How we can create a new node? What is the syntax we are having? P equals to
New node.
New node.
P equals to new node. So automatically a new node is going to be created. Next, P cap data equals to X. What is X? X means whatever the value we are retrieving. Yes, a value has been inserted. Is there any left child? Right now, I'm not going to take any left child. So what I have to write?
Null.
Left data, left child equals to null. So if I don't have the right child, then what I have to write? P
Right
cap
child equals to null.
right child equals to null.
Null.
First, both are going to become as null. So what I am creating, as this is the first node, this node I am considering it as which node? Root node. Yes, students?
Yes,
Yes,
ma'am.
miss.
Okay, now take out the next variable. What is the next value we are having? 3. So I want to insert 3. 3 is inserting where if I want to create a node, what I have to write? I have to write a temporary node. What I have to write? T equals to
New
new
node.
node. A new node will be created. T cap data equals to X. So the value 3 will be inserted. What is T cap left child? T cap left child is going to become as null. Yes or no? T cap right child also make it as null. What are the changes I need to do? P child should point to whom?
3.
To 3. So P's P's left child is equals to T. What are the changes we need to do? T we have to do. Yes. So
P cap left child.
Yes, 3 has been completed. Now take out 8. So what is 8? Again T. So T I'm going to create. So T cap data is equal to 8. T cap left child is equal to null. T cap right child is equal to null. Now, what is the relationship? P's right child should point to whom?
8.
To 8. Okay. So means we are taking out one after the one element from the queue, creating a node, and we are constructing a tree. Take out an element and insert into the tree. Take out an element from the queue and insert into the tree. The code, whatever we have learned in the double linked list, everything is going to be repeated once again. Yes, understood up to here?
Yes, ma'am.
Yes, ma'am.
Yes, okay. So take out each and every node and we are going to construct. Yes, first I'm going to write the create function, students. First today we will complete the create functions. Tomorrow, the day after tomorrow class, I'll work with the traversing of the nodes. So if you are copying, so if you are working directly on your system, so what are the concepts you need to take is, so first take a node, students, class node. Okay, you have to create node. So if you are working with the classes, if you are working with the structures, then that is up to you, students, because I don't want to create any confusion between you. So if you are convenient with the structures, work with the structures. No, mama, I'm working with the classes, go with the classes. Okay. So if you are working with the classes, so what we have to do, first step up, node star left child int data node star right child. Yes, students, please type this code. This is the first one. Okay, hash include IO stream. Okay, using namespace std. The first part is node part you have to write. Next, copy all the Q code, students. Copy all the Q code. What you have written, class Q. I don't know how many of you are having. So int size, int friend, int array pointer, int double dimensional array, constructor for initializing. Next, enq, deq, is empty, is full. Please write down all the Q code, students. All the Q code. How many of you are executing right now? How many of you?
I'm
Yes, 1, 2, 3, 3 people. Yes, those who are executing, okay, please follow this step. Those who are making a notes, at least making the notes, please write down the steps. So you have to write a node class separately. You have to write Q code, complete Q code, including your program. Then we are writing the tree program. 4 people are executing the codes, okay? Now, first we have to write is class tree. This is the third class, students. We are having node class, Q class, and tree class. Why we require node class? To create the node. Why we require the Q class? To retrieve each and every element from the queue, and we are constructing the tree. Okay, so that's why we require 3 different classes. Okay, in the node class, in the tree class, first one is create the node root. Node star root. If you people remember, each and every time while we are writing the linked list, I have taken struct node star p. Have you remembered, students?
Yes, ma'am.
Yes,
okay, every program, each and every program, whenever you are doing some creation, whenever you are doing some insertion, we have created some pointer, okay? P pointer. Similarly, as I'm working with the trees, the first one I'm going to consider it as root node. Yes. Okay, what I have to initialize with this? So take the constructor. Now root is empty, as we are going to write a struct node star b is equal to null. There we have written like that. Okay, here I am going to write the root equals to null. First, initially I am initializing the variable to null, or otherwise you can write a null pointer. The step one, please remember, the step one is creation of the root node. Okay, in the insertion operation, struct node star t also we have taken. I told you t, take a temporary node, insert, initialize the temporary node to null. Okay, take a pointer p, take a trailing pointer. We worked already all these concepts same way. When I'm working with the root, I'm not saying p, I'm not saying t, I'm saying root node. Okay, root and t. Take a constructor. Yes, students, the basic step understood why we are taking the root node?
Yes, ma'am.
Okay, thank you, Aditya. Yes, now take a function. This is important. Void create tree. Okay, so what are the pointers we have taken? We have taken only a root pointer. The root pointer has been initialized to null. Now, what I have to take? I have to take a pointer p. Okay, I have to take a pointer t. The reason is root value should be fixed, like your first pointer. Okay, in linked list we have taken first equals to p. Yes, similarly I'm taking root. P is pointing on the root. Next, to create a new node each and every time I require a pointer called as t. So take two more pointers over there. One is node star p and node star t. Root is fixed. Root always points to the first node only. Okay, root is not, we are not going to change. So the people who are having the doubt why ma'am is taking root pointer, why ma'am is taking p pointer, why ma'am is taking t pointer. So root always points to first node. This work already we did in the linked list. First pointer, I told you first pointer always points to the first node. If you are working with the circular linked list, head pointer always pointed to the first node. P pointer always keep on changing. Whenever a new node has been inserted, P pointer keep on jumping. What is T pointer? T pointer always creates the new node. There is no change. Okay. Now, to store the value, we require a variable that is called as x. To store the value, we require, means I'm saying x equals to 5, x equals to 8 or something. Okay. Now, call the queue initialize with the 5, because I told you to write the queue code. Okay, I want to insert 5 elements into the queue of 5. So calling this one. Now what I am going to do, first I want to set up the root. Okay, root ko set up karke, then I want to repeat the same procedure. So I want to set up the root, means root equals to new node. Root equals to new node. What happens? New node. So we have written node equals to 3 pointers, left child, right child, and data. So a new node will be created. Next. So as we have not read any value from the keyboard, so take the value from the keyboard, enter x value. C in x. So the people has entered the x value as 5. Okay. Now what I'm going to say, the root pointer storing the data value as x. So what will happen? The value 5 has been inserted. Who is pointing to this node? Root is pointing to this node. Root equals to new node. A root node has been created, enter X value, we had some value from the keyboard, and I want to convert that value into the root node. Okay, root cap data equals to X. Yes. Now, what will the left child should point? Now it is not pointing to anything. What the right child should point? Now it is not pointing to anything. If it is not pointing to anything, so what I have to take? Root cap left child is equal to null ptr or null, anything of your choice. Null pointer. Root cap right child equals to null ptr. So first initial setup we did, we created a node and we stored the data. The left child is pointing to null and the right child is pointing to null. Now, whatever the value we have taken, that should be inserted into the queue. So what I have to write, q dot nq of root is the total, the root value we are storing into the queue. Okay, so which value will be stored into the queue? 5 value is going to be stored into the queue. Yes, students. First step, initial step. This is the first step of any tree program. Now, left child creation, now right child creation. First initial step, what we have to do to create a root, first we, to create a tree, first we need to set up the root. If you want to set up the root, what we required a queue. Okay, we required a pointer to the root node. Okay, we required a P and we required a T. Okay, define all the variables over there. So what are the steps we have to do? First, root equals to new node. So there, for easy purpose, I asked you to take the array values. If you remember, P cap data equals to A of 0 means I'm taking a predefined array and I'm storing all the values into linked list. I'm storing all the values into the double linked list. Now I'm not taking any values from the array. What I'm going to do, I'm asking the user at that time only. Okay, enter the value, I'll construct the tree. Okay, first he entered a value as 5. I'm trying to convert it as a root. I'm not taking an array and I'm converting students. Please try to understand the previous one and this one. There we have returned P cap data is equal to A of I, A of 0, like that we set up the first node. Here we are reading directly from the keyboard and we are storing it as the root node. So see out, see in the value. Who is joining at this time? The good students. Yes, so root cap data is storing the data. Root cap left child is null pointer. Root cap right child is null pointer. Is it clear up to here, students? Any doubt? Setting up the root. First step, setting up the root. Any doubt? Yeah, okay. Now what I have to do, now I'm going to take each and every elements. Okay, so first I set up the root. Now I'm reading multiple values. Okay, so I'm taking the left hand side root elements or I'm going to take the right hand side elements. Okay, so arranging the elements and retrieving the elements. So the process should be clear. So how we have to do the process means, so whenever we are going to store NQ of root, what root is a pointer. What I'm sending the address to the queue. I'm sending the address to the queue. Queue means in which particular location I'm going to store this element. Some 2500 I'm storing the root node. Take out the root and check it out whether it is having left child or right child. Take out means remove. Remove means which operation in the queue, students? Removing means
DQ.
So now the continuation is while of, okay, if queue is not empty, then do the work. If queue is empty, show them. Okay, first one, P is equal to Q comma DQ. Take out the element. Which element I am taking out? The root element, because I am storing the root element address. Okay, so now root element address I am taking out. Some 2500 Who is taking out? T is taking out. Okay. Now I'm asking the user whether for this 5, root 5, and it is having any left child. So you write it down. Cout enter left child. Okay, Cn of x. So p cap data equals to x. So now I'm asking the user, do you want to enter any left child to this person? Yes, I want to enter the left child of this person. What is this value? The value is 8. So what I'm doing, I'm inserting the 8, already the value whatever we are going to store, whatever the address we are storing. Okay. Now what I am going to do, this value, whatever the value 8 we are taking, that should be left child. That should be left child. Okay. So now if the user is not entering any data, suppose there is no left child according to my view in the tree, I don't want to create any left child, I want to create only right child. Then what he will enter? He will enter -1. Okay, we'll consider that he is entering -1. So if he is not entering -1, if x is not equals to -1, okay, not equals to -1 means some data he has entered for the left child. So what I have to do, the first step is I need to create a node. Okay, Aditya. I need to create a node. If I want to create a node, which pointer we are having? T equals to
New node.
New node. A node was created. Okay. Now T cap data. Okay, I'm sorry. T cap data equals to x. Whatever the value we are inserting, that is going to be stored into the x. Next, what the T should point? T's left one is T's left child is null pointer. So this is going to become as null pointer. What is T's right child?
Null pointer.
Null pointer. So this is also going to become as null pointer. Now which two should get interlinked, students?
It's P and T.
P and T. So what I have to write? This
P
is
cap left child.
P cap left child should point to whom?
T.
T.
Yes. So P cap left child should point to T. Yes, the link has been established in between these two. Already in our queue, okay, so for the element 5, 2500 address has been stored. Now I want to store this address also into the queue. So what I have to write? Q dot NQ of T. Okay, so now the T address, some 3000, which value according to the value that has been stored. Take out and do the left and right. Now, which element I am taking out? First I have taken out the 2500 and I am inserting the left hand side. When I am inserting the left hand side, some new address I find it out. So I am inserting into the queue. Yes, I inserted into the queue. Okay, students, understood about up to here?
Yes.
Similarly, we are going to ask the user once again. Cout. Now we are working for only this one. Cout. Okay, if the user is entered the left hand side element, we insert the element. Suppose if the user is entering the right hand side, enter right child. There is no code difference. The code is the same, students. Okay, one thing in your mind. If your mind is thinking that mom asked to write a node code, mom asked to write a Q code, just now you check it out, students. Already we learned 100 times the same code only I'm writing. Enter right child. What I have to write? I have to enter an element. Cn of x. If user is entering the data, insert as the right. If user is not entering the data, insert as -1. So what I have to take? If x x is not equals to -1. It means he entered some data, okay, some value 10 he entered. I want to create this 10 as the right child to 5. So what I have to do? What are the steps I have to do? First, I have to create a new node. So the step is t equals to new node. New node has been created. Who created? T created. So t cap data is equal to x. So what the value he inserted? 10 he inserted. T cap left child is equal to null. Write down semicolon, students. T cap left child is equal to null pointer. And what is T cap left child? Right child. T cap right child is also null pointer. So both we are making it as null and null. So now which link we have to establish? T's right child should point to whom? T's right child should point to T. So
Right.
what I have to find? P's right child should point to T. Whatever the value you are inserting into the Q. So Q dot NQ of T. So this new address, some 3,500, the value 10 has been inserted into the Q. Okay. So if we are going to see where is the difference, students? Same code. -1, T is equal to new node, T is equal to new node, T cap data is equal to null pointer, right child, null pointer. In here we are inserting left child, here we are inserting right child. I'm asking the user only insert right child. So P's right child pointing to T, Q's right left child is pointing to 2. So insert that element into Q. Insert that element into the Q. That's it. So what happened? We have taken out how many elements? One element we have taken, consider it as round, take out that element and create the left child and right child. Now, for this 5, we created left child and right child. Again, go to Q. So, P equals to Q comma DQ. So, which element will be retrieved? 8 will be retrieved. I'm asking the user, do you want to insert left child? Then follow this one. Do you want to insert right child? Then follow the 6. Take out one element and we are inserting left and right. That's it. Yeah, students.
Got it, ma'am. Understood, miss.
Yes, students. So the concept is simple. Don't think that something new we are learning. Nothing. We are reading each and every element from the Q. But extra steps what we are doing is we are inserting, pushing the element into the Q. That is the next step we are doing. That's it. Reminding everything, the same repeated procedure. They're like this. Again, if I want to repeat the same procedure. So now what are the elements are there in the Q? So first we have take out 2,500 is the address of the first one. Okay. 5 is stored in 2,500. 8 is stored in 3,000. Okay. So 10 is stored in 3,500. So what are the addresses I stored? 2,500, 3,000, 3,500. Okay. So now this one we have already taken it out. Now again we are coming. While Q is not empty, is Q empty? No, Q is not empty. So which element I have to take it out? I have to take it out 3,000. So 5, 8, and this is 10. Now again I'm coming. P is equal to Q dot DQ. Which address I'm retrieving? 3,000. 3,000 means which element? For the element activation is for 8. So now I'm asking, see out interchange. If you want to insert the elements, yes, I want to insert the elements. Suppose my tree, I want to construct the tree like this. 8, 10, some 9, and 10 is there. For this tree, I don't want to create the left child. So enter left child. Simply what I have written -1. Means I don't want to create the tree. If I don't want to create the left child, if x value is equals to -1, so this whole thing is not going to be executed. Yes, stopped it. So enter right child. Now immediately what it will ask? It will ask enter right child. Yes, I entered. What is the value? 9 I entered. So first T is equal to new node. A new node will be created. P, where P is standing over here. P is standing over here. P is standing. Next, T cap data is equal to, what is the value I want to insert? 9. Okay. What is the left child? Null pointer. Right child, null pointer. Now P cap right child to null, P cap right child to T. Yes, P is pointing to T. Now this Q, this T's address, insert into the Q. So now T is storing in 4000. Insert into the Q. Now I completed for this 8 means 3000 address. I completed left part and right part. Now work has been done. Now for which node I have to start? I have to start for 10. Again, I'm asking the user, do you want to work with the left hand and do you want to construct? Means we are taking out the elements and we are asking the user, you want to insert into the tree, you want to insert the left child, you want to insert. Binary tree is very simple, students, because according to the elements we are getting, we are asking the user whether you want to construct the left child and right child. We are not doing any comparisons over here. We are not shifting the elements also. As it is, we are constructing the tree. In which order, whether we are getting smaller elements, whether we are getting greater elements, we are not worried. Just we are inserting the elements. Yes, is it clear for everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So what are the functions we are using from the queue? We are using DQ function. So compulsory DQ function you have to include in your queue code. Isempty function. You have to include the isempty function also in the code. And the next one, enqueue function. So queue codes, whenever you are writing enqueue, DQ, isempty, these three must be there, students. Then only the tree code, whatever we are writing, will support. Otherwise, it won't support. So combination of node, tree, and a queue. Yes.
Okay, miss, got it.
Got the point, students? Yes, yes, Pratimesh. Yes, is it clear for everyone?
Yes, ma'am.
Yes, ma'am.
Now the question is, suppose we inserted some elements, okay? If is like right child, then how it will be stored in there? You are arranging in the same way, na 5, 8, 9, 10, level by level order we are storing, na? Yes. No, don't store 0. Don't store 0, leave it. That I will say. Okay. I understood the point. According to the order of 2 into I plus 1. So what I have to store in the minus 1? That is your question, no? Yes. Yeah, I'll explain that point. Yeah, students. Now, wait for a second, Shauresh. So now the question is, suppose if I am going to have, now you take down the array one after the another only. Okay. So don't store any value for it. So now the question is how to print the elements. What I am going to store in the array. If I want to print the elements, what I have to do. So if you want to print the elements, students, we have to follow some traversals. Okay. So the traversals are going to be called as pre-order, in order, or post order. Okay. 3 different ways we have to write. We have to give the user that whenever you are writing linked list, simply you are writing display function and we are printing. Whenever we are working with the trees, okay, we have to give the student to the user 3 different or 4 different. Level order is not there for you. Better if you learn the level order also. So you are giving 3 options to the user. You want to print to the pre-order. So pre-order function we have to write. Otherwise, you want to print to the post order or you want to print to the level order. So the people who didn't attend my class, so once again I am repeating, for that we are going to write the code. Suppose if I am going to have a tree like this. 1. Now these are the elements of the tree I am inserting. Okay, so this is the tree. Okay, so in which order I am going to insert the elements? First 1, 2, okay, so 3, next 4 and 5. So this is strict binary tree and complete binary tree. Two concepts are going to be there. So if I'm going to take an array, there should not be any spaces, then it is going to be called as complete binary tree. Okay, fine. So I want to print the elements. If it is a queue, then I'm going to print 1, 2, 3, 4, 5. So I don't want to work like a queue. I want a different order. I want to work with the order. Yes, students, how many of you learn this concept? I don't know how many of you didn't learn the concept. Please learn the concept. We are having 3 orders, students. Pre-order. So the easiest way of pre-order is first draw the diagram like this. So if I am going to print the elements by means of pre-order, so the order I am going to get is 1, 2, 4, 5, 3. Suppose if I am going to use the post order, 1, 2, 3. This is the tree I have constructed. Just now we learned how to construct a tree, create function. So now I am asking the user, okay, so in which order you want to traverse? I want to traverse post order. Then how the output should look like? The output should look like this. 4, 5, 2, 3, 1. Suppose if the user has asked that he wants to traverse by means of in order. This is also a theory question, students. So 4. Yes, students. In which order I inserted the elements? 1, 2, 3, 4, 5. If I am traversing a tree, I don't get the order. I don't get the answer as 1, 2, 3, 4, 5. See the answers. 1, 2, 4, 5, 3. 4, 2, 5, 1, 3. 4, 2, 1, 3. None of the order is matching with the order what you have inserted. Yes, why we are learning trees, at least please try to understand at this point, students. This is the order I have created the tree. Okay, this is the order I am maintaining the records. Okay, so but I am not getting the answer in the same way. I am getting the answer in multiple ways. Yes, 1, 2, 3, 4, 5, one order of accessing the records. 4, 2, 5, 1, 3, another way of accessing. Is it same? Is the answers are same like stack and queue, students? In which order you inserted, in the same order you are retrieving? Is it same? No, it's not same. Suppose if I'm entering 1, 2, 3, 4, 5 and I'm constructing a tree, if I'm working by means of stack, in which order I can access the elements? 5, 4, 3, 2, 1. If I'm inserting the elements 1, 2, 3, 4, 5 like a queue, I can retrieve the elements also 1, 2, 3, 4, 5. If I'm constructing a tree by means of the elements 1, 2, 3, 4, 5, can I retrieve in the same order? No, we cannot able to retrieve in the same order. Different orders. Why different orders are required in real time? Okay, suppose there are 1,000 elements are going to be there. Every time I'm retrieving from 1 to 1,000, unnecessary time is going to be wasted to search a particular file. Okay, so that's the reason they don't follow the stack and queue concept to search the files. They files this non-linear data structure, students. If you want to search in the real time, they don't follow this stack and queue. So I inserted 1, 2, 3, 4, 5. If I am finding by means of in order, I can search the 4th element at the first place. Okay, 4th and 5th elements in the second place. By means of post order. If I'm working by means of pre-order, I'm searching the elements 1 and 2. So depends upon the elements. I want to work with the last elements, go for post order. If I want to work with the starting elements, go for the pre-order. If I want to search the elements in between, then go for the in order. Yes. Yes, students. At least now you people able to understand tree, queue, and ordering.
Yes, ma'am.
So we can't write any display function, students. We can't write. Please remember there is no display function in the trees. If you want to write the display function, so whatever we are drawing the lines that we have to convert into the code. Okay, pre-order code, in-order code, post-order code, level order code. Okay, so we have to develop the codes for this pre, in, and post orders. So 3 different concepts we have to write. Yes, at least clear up to here. Then I will write the functions in the next class: pre-order, post-order, and the this one. At least
ma'am.
clear up the create